If you've ever tried to get a generative AI to create a really specific image, like a lemon with a tiny chef's hat, alignment is everything. We want it to get our intent, not just get close. Today, we're doing a deep dive into a new framework called E-GRPO, that's short for Entropy-Aware Group Relative Policy Optimization. And our mission really is to figure out how it fixes a pretty big flaw in AI training by focusing on where the model is actually making real choices.
Exactly. We're talking about visual generative models, the ones that build an image in these iterative denoising steps. You can think of it like a sculptor chipping away at a block of marble. But the old approach, something like standard GRPO, it runs into this major problem because it treats every single one of those little chips as equally important.
So when you're trying to reward the model for getting something right, like making that chef's hat just perfect, the reward signal just gets lost across all those tiny steps. That's what they call reward attribution ambiguity, right?
Precisely. I mean, if the final image is off, which of the, say, 16 steps was the one that messed up? Because the model explores by injecting a bit of randomness at every single stage. All that built-up randomness makes it impossible to know which action deserved credit. It's like trying to coach a team by yelling 50 instructions at once and only giving feedback at the very end of the game.
That makes total sense. And the researchers found something fascinating and kind of counterintuitive about this. It all came down to entropy, which in this case is just the amount of randomness in the model's choices.
But they saw that in a typical 16-step process, the randomness in the second half, the steps that are closer to the final image, it barely matters at all. These low-entropy steps, they just create what the paper calls undistinguished rollouts. The model is just shuffling little details around, not really exploring anything new.
Which means that half of the training process is just adding noise to the reward signal. And they had data to back this up. They found that training on just the first 8, the high-entropy steps, actually worked better than training on all 16.
Right. And that insight is the entire foundation for eGRPO. It uses this adaptive entropy-aware strategy. So instead of just adding randomness all the time, it forces the exploration to happen only when the choices are actually meaningful.
Okay, but wait. If you start merging steps, doesn't that risk making the final image less precise? Are you trading quality for efficiency here?
That's the really clever part. They use a technique called step merging. eGRPO takes a bunch of those consecutive low-entropy steps, the ones where not much is happening, and consolidates them into a single effective high-entropy step. And here's the key.
Right.
All the other steps are kept deterministic. They follow a fixed path, which keeps the image quality high.
So you're just simplifying the exploration path. And because you're now only dealing with these big, meaningful steps, you get rid of that ambiguity we talked about.
Yes, and then they compute what they call a multi-step group normalized advantage, which is a fancy way of saying the final reward gets tied directly to that one big merged step. So you get dense, reliable feedback right where the model made its most important decision.
The mechanism makes a lot of sense. So let's talk results. Did it work?
It worked really well. eGRPO showed much faster and more stable reward growth during training. It hit state-of-the-art performance, beating the previous best, Dance GRPO, by over 10% on the HPS metric.
And HPS is the human preference score, basically how much people liked the images. What about aligning with the text prompt itself?
Right. They also tested it in a multi-reward setting with HPS and the CLI score. And it showed great generalization there, too. It improved on image reward by over 32% compared to the baseline. It's a huge jump.
You can really see it in the images. Qualitatively, the semantic grounding is just so much better. You look at these complex prompts like a papaya fruit dressed as a sailor, and the eGRPO model just gets it. The coherence is there. It actually understands what you asked for.
And that really confirms the whole idea that this selective entropy-guided approach is the key. It proves that learning from those moments of high randomness is what truly matters for stable and efficient reinforcement learning.
So eGRPO is a big step forward. It makes the AI's output much more faithful to what we actually want. But the research points out there's still a critical bottleneck: reward hacking. Even the smarter system can sometimes produce weird artifacts like random human faces appearing where they shouldn't, just by exploiting biases in the reward models.
The model is still just optimizing for a score, and sometimes that score doesn't perfectly capture the nuance of what a human actually finds appealing.
So that leaves us with a final thought. If the main bottleneck for visual AI alignment is now the reward models themselves, their inability to capture the subtlety of human aesthetics, well, how long is it until the AI itself has to be the one to design the criteria for its own good taste?